Okay, welcome back, dear students. So we have stopped here at this slide. Let us go on. The other axioms or corollaries of the probability are that if you want to find out the probability of the complement of any set, that would be probability of a complement equal to 1 minus the probability of that. Okay. Um, as you know that the total probability of any event can be 1. So if you want to find out the rest of the probability of the event, that would be the probability of event subtracted from 1. Okay. The probability of event is subtracted from the total probability, you will get the probability of the rest of the events. Okay. This is the proof. What we have done here, that if you know that the probability of a sample space is 1, and you know that what is a sample space will contain the set A and the rest of the set A. You can say that S is equal to the A union A complement. Okay, so the probability of S will be equal to probability of A union A complement. Okay, so as we know that the probability of the two events, if the two events are mutually exclusive, you know that if two sets are mutually exclusive, then the probability of A union B, again sorry for my writing, A union B is equal to probability of the event A the probability of plus the probability of event B. Okay. If two elements are mutually exclusive means that if A intersection B is equal to an empty set. So if in this case, in the complement set, in complement case, in complement set, the set and its complement will always be mutually exclusive. Okay, always A intersection A complement. This is understood that these two will always be mutually exclusive set. So if these two are mutually exclusive set, then the probability of this event will be equal to 0, and then it can be written just like this. Okay. So you know that the A union A complement is a sample space. It's a total sample space. So we have represented it by S and all the direction like this one. And the probability of a sample space, you know, the probability of a sample space is always equal to 1. So it is 1, and probability of A plus probability of A complement is equal to 1. And by replacing the order, we will get that probability of A complement. Probability of A complement is equal to probability of A complement is equal to 1 minus probability of. So I think it is now understandable. Okay. Let's move on. Okay. So what are the other probability actually? According to this axiom, the probability of any event cannot be greater than 1. Okay, the probability of any event A will always be less than or equal to 1. It cannot be greater than 1. So the proof of this is also written here, that if the probability of A complement is 1 minus probability of A, and the probability of A is 1 minus probability of A complement. So the A is written here because this is the maximum value. The values cannot be greater, these values cannot be greater than 1, because you know that the probability of the event A plus the probability of the event A complement will be equal to 1. So basically the sample space contains these two components, so that's why the probability of sample space is equal to 1. So the sample space is the basic authoritative set in any probability problem. So that's why 1 is the maximum value and the value cannot be greater than 1. So it follows that the probability of any event will be less than or equal to 1. So the objective of all this analysis is this one. Similarly, the probability of an event cannot be greater than 1 and cannot be less than 0. This is another corollary, and the proof of this is this one, which we have proved in previous corollary, and that is the probability of an event cannot be greater than 1. And in another axiom number 1, we know that the probability of A will always be greater than or equal to 0. So by combining these two, we will get this corollary, and corollary, that is basically corollary. I was pronouncing it incorrectly. So the value of it will always lie between 0 and 1. Okay, with an open interval, because 0 and 1 are also included. Let's move on. The probability of a null set is equal to 0. Okay, the probability of a null set is always 0. Its proof is here, because the probability of the sample space complement is equal to, you can see that the probability of sample space complement is equal to 1 minus the probability of sample space, as the probability of a HC, as the probability of, as HC is an empty space, because all we have is a sample space and nothing is beyond this thing. So that's why by replacing S of C, by replacing this S by this one, we can see that that could be here. And we also know that the probability of sample space is 1. So by replacing it here, we can see that at the end we will have this thing. So it states that the probability of an empty set is equal to 0. Okay. So now let's move on. Okay, this is the previous axiom, in which we can see that okay, let me share the screen again. Okay, let me continue with this. This is the same. This is the same axiom which we have seen before, that the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. We saw earlier that if two sets are mutually exclusive, then this probability will be equal to 0, and then the equivalent. But if the two events are not mutually exclusive, then the if the two items are if the two sets are mutually exclusive, then the probability of A union B will be equal to probability of A plus probability of B. Similarly, if the two are not mutually exclusive, then this term will be included. Okay, this term will be included, and hence we will have this is the actual term, this is the generic term. Actually, that if you have more than two events, then you can expand it as well with your own. And so the proof is also given here. Just give it a look. Let us move on. Okay, axiom properties, these are some other properties, commutative properties, and similarly associative properties which we have seen earlier for two events. If you want to see it, then the slides are, I have also shared the slides with you. Similarly, all these problems are also available in your book. Please give it a try, and that's it. Okay, 2.26. Okay, this is another corollary which says that if A is a subset of B, then the probability of A will be less than or equal to B. Okay, if A is a subset of B, it means every element of A is the element of B, but every element of B is not the element of A. So it means that the B can be B is a higher event in which more outcomes or most events are available, but in A we have much lower number of events as compared to the B. So the probability of the chance of the occurrence of event A is less than B. It can be less than or it can be equal to, but it cannot be greater than. Okay, give it a look. The proof is also here. You can see very easily that probability of B will always be greater than the probability of let's move on. So this is a practice example of which contains all the information of the axiom and corollary which we have seen so far. We have done it in our class, but let us do it again. In this particular example, and we have an urn which has 10 identical balls, and on each ball we have written some numbers which are from 0 to 9. Okay, the consecutive numbers from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then just like here we have different balls, 10 balls of equal size. Okay, so 10 balls, 1, 2, 3, 4, 5, 6, 8, 9, and some numbers are written over these balls. This is 0, this is 1, this is 4, 5, 6, 7, 8, and 9. These are different balls which we have put in or the basket. A random experiment involves selecting a ball from the urn and noting the number of the ball. Okay, you have to select a ball. You have to select a ball from the urn, and then you will be noting the color of the ball. Okay, selecting a ball and noting the color of the ball. Find the probability of the following events: event A, event B, and event C. These are basically the three events. What is the event A? Event A is the number of balls, selected ball is odd. All numbers are 1, 3, 5, 7, and 9. What is the event B? Event B is that the number of balls selected is a multiple of 3. 3, 6, and 9. And the third event is the number of balls selected is less than 5. That would be 0, 1, 2, 3, 4. So, and similarly, I have to find out the probabilities of the event A union B and A union B union C. So, what is the first step? By solving all these examples, you have to, for solving all these examples, you have to follow some rules. In rule number 1, you will have to write the sample space. The sample space is very important. So what will be the sample space of this for this problem? That would be all the elements from 0 to 9. Okay. Then you know the events which are written in words. You have to write those words mathematically. Okay. So by writing mathematically, you will write the set A will contain those numbers in the set in the form of set. The event B contains the following numbers, 11, C contains the following numbers, and so on. And then you will calculate A union B, A union B, union C. After calculating these things and writing these things, you will count the number of elements in the event A, number of elements in event B, number of elements in event C, number of elements in event S, or the sample space, number of elements in the event A union B, and the number of elements in the event A union B union C. Okay, when you will calculate it, then use the frequency formula in which the probability of any event is equal to number of elements in the event, let's say event A divided by the number of elements in the sample space. This is the probability of the event. So by using this formula, you can calculate any probability function. So let's go to the solution. So in this solution, you can see that. Okay, let's in this question, basically the same steps are followed. Here first sample space is calculated, then event A is calculated, sample space is written, event A is written, event B is written, because that was event A. What was the event A called? That was the event A was basically the odd numbers, the occurrence of the odd numbers. Event B was the occurrence of the all elements which are the multiples of 3, and event C was the event of all the elements which were less than 5. So by writing them like this one, 5, what is the probability of A is equal to the number of elements in event A divided by the number of events in the sample space. So the number of elements in event A are 1, 1, 2, 3, 4, 5. So by writing 5 here, and the number of elements in the sample space are basically 10. So writing 10 here, we will get 5 by 10, and that is 1 by 2. So the probability of the occurrence of probability of A is 1 by 2. Similarly, for finding the probability of B, we have to write the number of elements in set AB and the total number of elements in the sample space, that is 3 by 10. Similarly, for C, the number of elements in the set C divided by the total number of sample space. Okay. You have calculated all the three. You have calculated all the three required results A, B, and C. After it, we have to find out A union B. There are two methods. You can find out the value of A union B from this set. Okay, from these two sets, you can find out the A union B, and then using the same method which I have used here. Or second method is this one. Probability of A union B is equal to the probability of A, which you know, probability of B, you know, and the probability of A intersection B. Okay, we can use it like this. Just a moment, please. Okay. So this is another method in which you can calculate probability of A union B. That is probability of A plus probability of B minus probability of intersection B. You have to find the value of A intersection B, and then you will write it. Okay, probability of A intersection B is that. Okay, then probability of A union B, that would be probability of A plus probability of B plus probability of C. These are the three, right? Because the three are not mutually exclusive. You will write probability of A intersection B, probability of A intersection B intersection C, B intersection C, and that probability of A intersection B intersection B. This formula is very important. You can use it. You will use it for finding the probability of the union of three events. Okay. Let me mark it. This is a very important formula. This one, just like this formula, this is for the two events. You will use it for the three events, which the three events are not mutually exclusive. Okay. So after finding the value, after writing all the values, you will get that time. Okay, there are other methods as well. You can try those as well if you want. So this is the method I have tried here because this is more related to the axioms and corollary we have discussed so far. There is another example that is in exercise 2.37. Just give it a look and solve all the examples in your book. Finally, solve them and deduce what it wants and what is it telling you about the concepts of probability. Okay, so this is your task as well. Basic probability properties using axiom, we have done it. We have done it before, and with this exercise, you have to show that the probability of A union B union C is less than or equal to the probability of A plus probability of B plus probability of C. Okay, so by using all the corollaries, please take a look and you will see that the probability of A union B union C is always less than or equal to the total probability of A plus probability of B plus probability of C. If the events are mutually exclusive or not. This formula is for all the cases. It's the generic formula. Okay, let's move on. Okay, this is another formula. As we have discussed earlier on, that the probability of A union B, probability of A union B is equal to the probability of A plus probability of B minus probability of intersection B. This formula generalizes those theorems. Okay. Those formulas. Sorry, this equation generalizes those formulas, and you will see that by writing any number of the events, you can use this one. It's very good for your understanding, but in this course we will not go beyond the probability of 2 or 3 events. So it is good to have a look at this one, but we will not go beyond 2 or 3 events. Computing probability using counting method, we have already done it. What is talking about that if outcomes are equally likely, then the probability of an event is equal to the number of outcomes in the event divided by the total number of the outcomes in the sample set. So this term is very important. Whatever we have done so far is basically assuming that the outcomes are equally likely. No outcome is more probable than the other one. The probability of all the outcomes will remain same as we will use this formula. Like that, if you want to find out the probability of B, then the number of elements in set B are A, and the total number of elements in the sample space are N. So you will find the probability of event B by using the formula K by N. Okay. So that is the formula, and that is what we have. Okay. This is another problem. What is this problem about? That if you want to find out the total ways of performing any action, how would you count it? I have given you this example in your classroom by using the 2-bit counting. Okay, so let's do it again. Left, how many combinations can you get by? How many combinations you will get from a 2-bit number? Okay. Let's say in the 2-bit number you have two spaces. In first space, how many choices do you have? Let's say you have 0 and 1. How many choices do you have for this first spot? You have two choices. Either you can write here 0 or you can write 1. So you have two choices for this spot, and you have how many choices do you have for this spot? You again have two choices. So by these choices you will get 4. Total number of combinations of 2-bit numbers 0 and 1 would be 4, and that would be 0 0 0 1 1 0 and 1 1. Okay, these are basically three combinations. Similarly, if you have not the binary numbers, but you have the numbers from 0 to 9, 10 numbers, how many combinations can you have? How many combinations can you have? You will have, how many choices do you have for this first spot? 10 choices, because this is with repetition. 10 choices here, and how many choices do you have for here? You again have 10 choices, so you will have 100 choices. 100 number of combinations you can make out of these 10 numbers by using 2 at a time. Okay, so I think it's understandable. sorry, that if you have, if there are, if there are and one ways of doing something and two ways of doing another thing, then there are and one multiplied by and two ways of performing both actions. Okay, there are and you will have to multiply them if you are using with replacement. If you are using without replacement, if you are using without replacement, if you are using with replacement, that problem will be used later on. Okay, just like here, a person named Aslam wants to buy a car, and the choices he has are Honda, Toyota, Suzuki, Nissan. Each company has cars in 6 colors. So how many choices do he have to how many choices do he have to buy a car? So he will have 4 multiplied by 6 choices, because in 4 companies he will have 6 colors. So 4 minus 24 choices he has to buy a car. Okay, just give it a try. You will it's a very easy problem, and we have also done it in our class. Okay. If you have more than 2 spots, then you will again multiply them. Just like here, if you have 3 spots, then you will use and 1 and 2 and then 3. Okay, you multiply them with choices and you will get them just like you 3-bit number. You have how many combinations you will get from a 3-bit number. If you have a binary combination, then you will get 8. How? Because in the first part you have 2 choices, in the second part you have again 2 choices, in the third part you again have 2 choices. Then how many choices will you have? You will have 2 to the power 3 choices, and in this way, and so on. Okay. So this is a second problem that which is asking you to find a multiple choice test. A multiple choice test attached to 10 questions with 3 choices. In how many ways are there to answer the test? Because for each question he has 3 choices, so 3 multiplied by 3 multiplied by 3 up to 10 times you will have 3 rest of 10 total choices, and that is what he has to do. So I think it's enough for today, and in the next class what we will discuss the remaining concepts and remaining theories, and what you have to do. What is the thing you will do is you will try to please try all these things, and in our session at the class interactive session we will again discuss these things. If you guys have any ambiguity, if you guys have any questions, just write it over a paper and ask me in the interactive session. Similarly, what I want to tell you guys is to practice these theories and these questions a lot. If you will not practice these things, these will vanish out of your mind, and you will not be able to do these things in your examination. Exercise questions and example questions are very important to solve, and I will again give you some other things and other topics which are very important for your exam and your understanding. So thank you so much, and see you guys in the interactive session. See you. Allah Hafiz.